Well, let's go ahead and get started. Again, I'll say that my name is David Sanders. I'm department chair here at the Department of Civil Construction and Environmental Engineering here at Iowa State University. And we're excited that we can do a town hall webinar today with Dr. Kaoru Ikuma. Before we get started, just a few comments. One, this session will be recorded. There is an opportunity for a closed captioning feature that you can turn on in the bottom left-hand corner of the screen. We will be able to have interaction between Dr. Akuma and the audience through menti.com. You can open that up as a separate window on a separate browser on your screen or on your smartphone. There'll be a session number that we will give you later that will enable you to provide interaction. And then also we'll have time at the end for Q&A. So let me introduce to you Dr. Ikuma. So Dr. Akuma is an associate professor here in the Department of Civil Construction and Environmental Engineering. She came to us in August of 2015 after getting her PhD in Civil and Environmental Engineering at Duke University. She's been a great addition to our program. Her expertise is environmental and microbiology, biotechnology, water quality, and community-based research, which is a lot about what she'll be talking about today. And she was especially critical in the starting of our BS in Environmental Engineering program, which is in its third year. So with that, I'll turn it over to Dr. Ikuma, and excited to hear the seminar today.
Thank you, Dr. Sanders. So let's go ahead. So, oops, this clicking the button that takes a little bit of force here. So we're here today to talk about, or to just give back to the community, to give a sense of what we're doing in our environmental and water resources engineering faculty and the focus area as such. And the title is A Future of Environmental Equity, and I'll tell you a little bit about why we decided on this topic today. But before we go there, I just wanted to give a big shout out to our new Bachelor's of Science degree in Environmental Engineering. We started it in 2020, and we have had 2 cohort graduates so far, which is exciting. And I think perhaps some of them are here today, I'm hoping. I just wanted to give you a quick overview and then let the students speak for, instead of you listening to me. We have a good, strong enrollment, more than we initially projected. In fact, this year, so I'm only showing up to last year, academic year. This academic year, we have about 45 new students. So it's growing very, very rapidly. We're a little bit actually overwhelmed, but it's in a very good way. I do want to highlight that what we really, really emphasize in this new major is hands-on coursework and very close student-faculty interactions. So a lot of it, we're making it such that they have environmental engineering courses from their first year to their second year, rather than only getting to take specialized courses until, or they have to wait until their third year. They really do a lot of the hands-on research, hands-on monitoring activities their first 2 years, in addition to all the obviously technical advanced courses later in their curriculum. So I just wanted to give you just a short video of some of our recent graduates in our program, and I think, again, their voices speak for themselves.
Environmental engineering seemed like the most beneficial to not only the things that I'm building, but everything that surrounds it, the systems, the land, just, the people.
All the time in the news, you hear about these really complex issues, whether it be Flint, Michigan, or Jackson, Mississippi, or any of the like. And in environmental engineering, you get to take those really complex issues and develop actual solutions, both mathematical, science, social, and actually get to help people.
I wanted to do something that made a difference and have a career where I could help people out.
I think it makes the learning experience better when the people that you're surrounded with in your major are also just as passionate about the topic that you are. And so it makes group projects actually like something that I look forward to, and aptly molds what I'm going to be experiencing in the real world.
I feel like I've been able to improve my problem-solving skills a lot. We've been given the chance to do a ton of different group projects and class projects, so I've been able to work with my peers and make decisions with them and really focus on the direction I want to go personally within environmental engineering.
I would say that my time in environmental engineering has given me a lot of resources in terms of the professors and the materials that I'm able to kind of learn from, especially when it comes to a lot of the undergrad research opportunities.
I'm hoping that I can do things like environmental justice work and just generally help the projects that make it so that we keep our water clean and our air clean and make it so that people are actually happy and healthy whenever they go out to recreational areas or just generally exist in the world, and that we're not harming the environment in a great way whenever we do such things.
I plan on going for a master's here at ISU in microbiology in relation to water treatment, wastewater treatment plant design, and I plan to work in the public sector.
I plan to use my degree to help protect the environment from the contamination we produce, as well as make sure people have clean water to drink on a daily basis.
All the doors are open right now and everything's up for grabs, so my goal is to just get out there, do stuff that is going to help communities, help the people, help the environment.
So I'll be using my degree to focus on water quality in the future. I think this has been a really big issue recently in the US. So I want to go in the direction of drinking water treatment and wastewater treatment to make sure that communities in Iowa and all around the country can get the safest water that they can.
My name is Tracy Seedam. I'm an environmental engineer and I will be graduating spring 2023.
I'm Emma Lindy. I'm an environmental engineering major and I am graduating in spring 2023.
I'm Chloe. My major is environmental engineering and I'm graduating in the spring of 2023.
My name is Logan Didier. I am a senior graduating in the spring of 2023 in environmental engineering.
My name's Cal. I'm a senior in environmental engineering, graduating in 2023.
So I will actually note that they all did graduate. We took the video back in April, so they're saying I will be, but they all did graduate, and that's our second cohort, part of our second cohort who graduated. I wanted to, so that's the big shout out to our bachelor's program. I also wanted to give a brief overview of, or an update on what we're doing on the research front, because as you all probably remember, us professors, we often want to do teaching, but also cutting edge research that will then inform our teaching. And so to do so, I not just to talk about myself, but I wanted to highlight a big project that most of us in the focus area are on, that is funded by the Environmental Protection Agency. We started this in September of last year, so it's in our first year. We're finishing up that first year. It's a 4-year project, so we're really just ramping up and doing really good work here. The project is titled Accelerating Technical and Community Readiness for Water Reuse in Small Systems. Excuse me. So first up, so I wanted to ask you to go to menti.com and use this code. This code will go for this question and one more question. So keep that code going. It's 44459491. And tell us, what keywords do you think of when you hear water reuse? And it can be broad. It can be, again, whatever you feel like, or whatever you think of. And while you're going there, putting this code in, I'm going to pause my screen share, go to that myself, and start the Menti presentation. So please go ahead and start that word cloud. So again, the code is 44459491. Excellent. So I see great keywords. So we got things like recycle coming up. Let's see, wastewater treated. You see things like potable water, toilet to tap, reclamation, efficiency, brown water, one water, collection, circulation, sustainability, circulated economy. All these are excellent keywords and is really what we're like, does encompass what this project is about. So let me give you a brief overview. Let me go back to that one. Brief overview, if I can actually get here, of this project. So again, it includes professors, faculty from environmental engineering, the classical environmental engineering, as well as water resources engineering, and multiple institutions beyond Iowa State. But we are the lead institution here. So, and it does come down to this one water cycle. So I was happy to see that one water come up as a keyword. So many of you might have seen something like this. Basically, the one water cycle is talking about how water cycles, we know that, not just in the natural environment, but also through urban environment. So the one water cycle focuses especially on these more urban or human-centered systems, excuse me, where, we know that we use water to make drinking water or potable water that is then used by people, becomes wastewater, and we do wastewater treatment. Those are the classical parts of water that we tend to focus on in environmental engineering. Beyond that, it still is, there are smaller or less focused arrows that happen here. For example, from here, so here's our water treatment plant and our water towers going to the houses. Wastewater gets generated, goes to their wastewater treatment plant. But in between, there are different types of reuse or reclamation that happens to these waters. There's also different ways of discharging that water from the wastewater treatment plant. There's a fact that there could be de facto reuse, where treated wastewater goes into the natural environment and then gets picked up for drinking water. So can we take this and think about how be more deliberate in our design of our systems, knowing that this kind of water cycle, the one water cycle, can get smaller and smaller. The loops can get smaller as we face climate change and water scarcity. And another thing, so when we think about this one water cycle, a lot of the emphasis in the discussions in the field have been about these larger urban systems, cities, and so forth. But the question that we wanted to pose for this project is, what about small rural communities? This might be near to our hearts, especially in Iowa. If we look at U.S. drinking water systems and look at the percentage of systems within each state that are considered small, and that definition of small is serving 10,000 people or less. So then we start seeing some aggregation of states that have a lot of small systems, and Iowa is one of them, is in the top 10 states. So we are here on this map. Oh, sorry, here on this map, I was pointing at the wrong screen, and we have between 95 and 100% small systems. So most of our water systems that serve our people are small. And that comes with certain connotations, certain challenges that are very difficult to overcome, from financial to workforce to a lot of different things. And I'll come back and ask you that question later. So we wanted to specifically focus on small systems and think of the possibility of water reuse in these small systems. And that's really the main goal here, is to increase access to safe water. So can we make our systems more reliable in the face of climate change, in the face of a lot of things, in the face of human disasters as well, so that our people will be guaranteed to their what should be their right to, that is to access safe drinking water. So just wanted to note here that the 3 academic institutions involved are Iowa State, again, we're the lead, I am the lead principal investigator, University of Rhode Island over here, and then University of California, Berkeley as well. So, and we are targeting some communities in Colorado, Iowa, and beyond as well. Yeah, so I asked you about this water reuse. The toilet to tap came up, wastewater treated came up. That's a great starting point, and that's typically what people think of when they hear water reuse. In this project, and deliberately, we're really defining it very broadly. We're not talking just about municipal wastewater becoming potable water, indirect or directly. We're also trying to think about things like as simple as rainwater. Can we consider that reuse? If we do define it broadly, yes. Or stormwater that's runoff onto urban surfaces, agricultural runoff, all these things. Can we think about how broadly to reuse water that is traditionally considered waste or unusable or very difficult to use, and make it something usable, regardless of whether that's potable, drinkable water, or non-potable water that replaces the use of potable water. Okay, so that's our definition here. Another thing I wanted to ask you is, what are some key barriers that you can think of for small communities, 10,000 or less, to adopt water reuse with that general big, broad definition in mind? And I say small communities, I say 10,000 or less. In Iowa, a community of 10,000 is probably considered pretty large. And we are not talking just about these thousands here, but also communities in the hundreds, 500 or less people, maybe 1,000 or less people as well. So think about all those communities. Please go again to menti.com and use this code and think about all these possible parameters and tell me what you think will be some of the key barriers. Let me go to that real quick while you're doing that. Okay, let's see here. Right. Here we go. So again, the same code, 4445-9491. Hopefully you can see the second question. And just cast your vote. I think I allowed for multiple votes. You don't have to stick to one thing. And it is more complex than one thing. Excellent. I think we got some of the votes and still coming in. Keep them coming. So I had the parameters I gave you were cost, safety, human capital, politics, regulations, technology availability, water data accessibility, public trust, and other. I'd be fascinated to hear what the others is or are other category. I can think of multiple, but I probably should not give you tens of options here. So I think we got our votes in. Top one was cost. That is one of my big concerns as well. Next one comes technology availability, or then public trust. There's some votes for human capital, so the people, the human resources, and who is there enough expertise there. Politics, big one. Regulations. There's some barriers or people who thought safety was a barrier, water data accessibility was a barrier. And so I know this is kind of it's an obvious thing to say, but honestly, all of these are barriers, but we had to choose some key ones to consider in our project. And it will come back to a lot of what you have already told me. So let me go back to the PowerPoint. Okay, here we go. Okay, here we go. So of these, you gave me cost as a major one, technology availability as another major one, public trust, and many of the other things. So what we are doing in this project, I won't go through this, it's kind of boring here, but the goal here is to accelerate water reuse adoption in small rural communities by increasing technical and community readiness. Really, again, the major thing is to provide communities with opportunities to diversify their water portfolio and supply, and just make their decision-making more robust in the face of a lot of challenges that we don't have control over. So here's our roadmap. I really like this figure, so I show it all of them. But really what we're looking at is what the key barriers that you identified were. So it's things like health and technology, water data, organizational and social barriers, and cost that is associated with every single part of this. We are taking what's called a convergence approach. So where we have to think about how technology and health converge, have a good sense and tools to understand that. We have to think about how water data, like how much water is available for a given community, how do we make that accessible to the communities, and how do we converge that with technology and health. And then on the organizational and social aspect, organizational means community, the regulation aspect, the community structure, the decision-making. Social, we are considering people's willingness to pay for water reuse or reused water, and so on and so forth. And then ultimately, can we come up with what we call a windows of opportunity framework? Are there specific windows of opportunity for these small communities where it does converge, it does make sense for them to spend a little bit more money, and a little bit, I know it's not that little, but more money to do something that will extend their readiness for water reuse, and again, build resilience in their decision making. So this actually is coming off of the EPA's Sustainability Managed Utility Framework for Small Systems. So we started from this. There's a lot of things that go into it, and I won't go and talk about every single thing. And we adopted it and modified it and said, well, okay, so if we want to think about sustainability managed small systems exhibiting readiness for water reuse implementation, here are the necessary things. And here, the arrows in red are the things that we think as being key barriers. Again, coming back to a lot of the key barriers you have already identified. So, and we're trying to tackle them sort of one by one, but also converge. This is a busy slide. I just wanted to show you the scope and scale of things and where we all fit in. Again, 3 institutions, 11 investigators, and then a lot of graduate students as well. So you might see some familiar faces here, including, of course, myself, but a lot of the professors you might have had in classes, or you know from your time at Iowa State, or from your time seeing and interacting with our department. So lots of things here. I just wanted to show real quick some of the key things we're trying to do. And we have 5 key objectives, with the 6th one being actually testing things out in the communities. First one is overcoming our water information barrier. So especially because we are defining water use very broadly, communities, especially small communities, probably don't know how much water, rainwater they can access, how much stormwater runoff they would have, ag runoff, let alone surface water, groundwater. Do they have the ability to find that information right now, right here, and easily understand it? And the answer is likely no. So can we bridge that gap and help understand things like, what scale are decisions being made? How do we support those decisions? So this is largely done by Dr. Arenas and Dr. Liu and Dr. Raymond. We are putting together an app on Google Earth Engine where we let the communities basically choose, okay, here's my city, border, there you go. Within this border, how much water do I have? Or maybe for them, it's more relevant that it's at the county level or watershed level. So we're giving this versatile tool for small communities to just click something and it'll compute the amount of water they can expect, and also have predictions with different climate change scenarios. So water, now they know how much water they have. Another tool that we're developing is to overcome the technology barrier, and technology was one of the barriers that was identified here. Can we come up with a strategic scan of technologies that would be viable in their communities? This is just really a spreadsheet tool for them to say, okay, we have this much money, so we're going to screen out these things, too expensive. Here are, the remaining things we want to do. We want to use rainwater to potable water or wastewater to non-potable. We'll have all these different combinations that they can search from. So this is to account for that big barrier of technology availability. Another thing is to make a cost curve tool that actually brings into account a lot of the undefined or very difficult to define things like environmental benefits, in addition to the technology costs, the capital costs, and so on and so forth. Can we have make this tool and make it more robust and approachable or accessible to small communities to help their decision making? So the cost part comes here, and we're trying to address that here. Social barriers, willingness to pay. Are people in these communities willing to pay a little bit more or not to get reuse going, to, again, diversify their water portfolio? What are some organizational barriers that cities, communities have? And trust was one of them, is coming into here. How do we build that trust or mend the trust, mend any distrust that might be there? And regulations also come into here for the organizational barriers. And ultimately, we are trying to do case studies focused on these windows of opportunity and really trying to get rid of these barriers that are stopping that arrow. And how many of them can we get rid of and therefore allow that flexibility for small communities? Now, these case studies, we haven't identified exactly where we're going to do it. It's likely going to be in Iowa, Colorado, Rhode Island, maybe some more states, especially these dark brown states that have high percentage of small systems. We also are interested in looking at what is the impact of the infrastructure bill or the Infrastructure Investment and Jobs Act. And now that money will be available or is available to these small communities, how can we take advantage of that or help communities take advantage of that better? Now, this is the pitch I have for you, and there is a pitch here. We do have collaborators. We have various collaborators on the environmental justice side, policy side of things, consulting engineering, some state departments. Ironically, I don't have Iowa DNR here, but I will get them on board, and cities. But really, coming back to this project that we're undertaking is large in scale and scope. And really, we need to be hearing voices from all sorts of sectors to help these small communities. So what it comes down to is we are looking for more collaborators, especially our alumni who are in the field, hearing things, doing things, seeing things. If you have any feedback or suggestions, or if you're interested in being part of this project, please reach out to me. I'd love to hear it. And love to find ways of collaborating, or at least taking advantage of your expertise and your experience and knowledge to ultimately help Iowa communities and beyond. So that's our quick and dirty overview of a major project that we're undertaking. It is one of many, many, many research projects that are happening in our focus area. There's a lot happening. It's an exciting time. So please also, if you're interested in other things that we're doing, reach out to me or anyone of the faculty. We'd be happy to talk to you and to chat and to highlight other things that we're doing. So
well, thank you, Kaoru. This has just been very informative and outstanding. I've noticed that there's a comment in the chat about, I assume, the town engineering expansion will help with this space issue, and That's absolutely true. For those of you that may not be aware, and maybe Alicia, you could put a link in the chat to our website that talks about the town engineering expansion. We are planning a $30 million expansion onto the south side of town engineering. Town engineering, for those of you that may not know, is the building for civil construction and environmental engineering. We occupy basically the entire building. There are some general purpose classrooms or university classrooms on the second floor, but the rest of the building belongs to civil construction and environmental engineering. The building was built in 1971, and at that point in time was a shared space between aerospace engineering and civil engineering at that time. Since then, in 1999, aerospace moved out, and we've changed our name to Civil Construction and Environmental Engineering, and we've basically consumed the entire building. But I think what's even more important is a building that was designed in 1971 was really very much a lecture-based teaching type of building. And so the amount of collaboration spaces that we have in the building and the sizes of our spaces are quite small. And so the focus of the expansion is creating large collaboration spaces, whether they be informal spaces like a lobby, breakout rooms, conference rooms, and then also team-based classrooms. And then the last component is also just moving our advising center, which is on the third floor of the building, to the first floor of the building to create a very student-centric space for our civil construction and environmental engineering students, but also other students in engineering as well as the campus. But as Kaoru has mentioned to it, one of the flagship rooms of this expansion is a new wet laboratory for our environmental engineering program. In the early slides, if you weren't here, she indicated the very quick growth of the program, already over 100 students. And so our existing laboratory, again, was essentially built in 1971. And so for a civil engineering program with an environmental emphasis. And so the new space is larger, includes much better equipment in terms of the environmental side, but also in terms of the audio visual and the interaction between the instructor and the student. So I'm particularly excited about that room. And I would be remiss to say that we are in the process of raising money for that. So if you or you know of somebody or you have a company that might be interested in donating to that, we're excited about that. And you can contact me for that, David Sanders, or you can go to the link that Alicia Carroll has provided. So always be nervous about asking a chair a question, goes on too long. But so let's go back and just say thank you to Kaoru for this webinar, and also thank you to all of you for participating. Our plan is to do these more frequently throughout the year. So stay connected with our program. If you aren't on our mailing list, please contact Alicia Carroll and she can get you connected in, and look for other opportunities to learn more about the great things that are going on here in our department. So have a great day, the rest of your day. And in Iowa, we would definitely say today, stay cool. It's a nice hot day here in central Iowa. So again, thank you very much and take care.